Good morning, folks. This is tutorial number 23, which deals with a, uh, the simple rule that can be done in 3D Experience in order to specify the kinematics of uh, a problem. Now, what I did in tutorial 22 was a simplified version of this, where it involved only a prismatic joint, basically a box traveling down a track, and I wanted to actually write a few lines of code, which obviously 3D Experience calls it the rule, in order to follow a certain pattern. Now, I also want to remind you it's important for you to watch that tutorial 22 because it tells you what are the other ways of doing it beyond or aside from writing a few lines of code, okay? Now, the difference between this tutorial and 22 is that there are two joints here. One of them is a revolute joint. So we have this arm that's rotating about that base, and there's a prismatic joint which uh, basically the slider that slides down this track. Now, uh, it is possible to do this problem with other ways, as shown in tutorials 2, 3, and 4, but I'm going to use simple rule in order to do that here. And notice that the, the, the displacement, the displacement of the slider and the angular position of the arm are plotted here, and this is actually what I want to code, but the breakpoints are the same. See that? When, for example, between 0 and 3 seconds, these have the same expression. The same expression meaning that we have a formula here, a law here, or a rule here. Between 3 and 7, something happens to these, and between 7 and 10, something happens to these. Now, tutorial 24 is going to be where these breakpoints are not necessarily the same. For example, when this was, let's say, I don't know, 3 seconds, the arm keeps turning. It keeps turning. Uh, because if you want to do it the way it's described in this tutorial, there's going to be a lot of lines in that code because you have to break down into different intervals of time. Here I'm going to have only 3 times interval, but if these breakpoints are not the same, then you may end up with 5, 6 breakpoints, if statements, and then it's easier, if that is the case, as done in tutorial 24, to write two rules, one for the prismatic joint and one for the revolute joint. But here I'm going to write a single rule. Okay? Now, uh, how do you get to this business of rules? Well, when you create a scenario, look at the Tools tab, okay? And here's Scenario, Tools tab, and you're going to see this, which says Simple Rule. It is also possible to get to this point by going to a different application, which I'm not going to bother doing that. So basically, you can see that the icon says if ... So it is writing a program, essentially. Now, that's what I'm going to do. And notice that uh, as I will lead you through the tutorial, the first thing the first thing is you try to after you create the assembly and the joints and things like that, you create the excitation. These two are created, and I'm going to use a law excitation. As soon as you do that, two formulas are created, but don't do anything to these because eventually these are going to get deactivated and your rule is going to pop up, okay? So anyway, just wanted to point out in tutorial 22, I mentioned that it's very fussy about how you write these things and there are other ways of doing it. But for example, the slope of these lines, I'm just doing it the lazy way, 180 degrees divided by 3 seconds. If you go back to the graph that I had, for example, these are the slopes of those lines, okay? Now, one other thing is that as soon as, if there are no syntax error, as soon as you create this rule, when you say, okay, it's going to come back and says, hey, you told me that there are formulas here. If you want to do that, do you want me to deactivate the formulas and instead use this rule? And the answer is yes, okay? All right. Now, Once you write your rule and everything looks good, no syntax error, if you put the cursor on scenario and right click, it says, do you want me to plot the exploitation? This is a good way to check your work. And if you do that, you're going to get these curves, which are exactly what my job is to input. Now, notice that these are deactivated, by the way, here. I will come back to these slides later on when I go through the actual tutorial. But if you double click on this line, this dialog box opens up, and notice that there's no formula here. This is turned into that little if thingy, okay? And if you double click on the other one, this opens up, and if you left double click on any one of these, it'll take you to the code, and you can make modifications as needed. Okay, and this is tied to the book that I did 9 years ago, right, with 2016X. All right, let's go ahead and do that. All right, so we go here. It takes me maybe 3-4 minutes to create these parts, but it's worth it because I'm assuming that you start from scratch. So let me start with an assembly. Now, first thing, I'm going to insert the part. Remember, dimensions are not important in this problem. I don't want to worry about dimensions, so I'm going to say insert a 3D part. Immediately, I call this thing base, properties, base, and base. Okay, I don't know why I made it kind of complicated when I drew these things, but that's okay. Simple. So on that horizontal plane, I will sketch. I'll draw a circle here, exit, and then pad it. Okay, good. On that face, I'm going to draw another circle. This is to make the base. It doesn't have to be this fancy, but why not? Two concentric circles, exit, and then pad. Okay, so basically what I have here is the base right there. Then I'm going to do the arm. So all the way to the top, right click, insert 3D part. I'm going to call this thing the arm, properties, arm, and arm. Okay, good. Double click on the 3D shape here. Let's make the arm. So on that plane, I will sketch. Sorry, on this plane, I will sketch. Why don't I project that circle? Uh, project, where's the project? Yeah. Project that circle, and then I'm going to pad it. Exit, pad it in the other direction. Where did it go? Flip the direction and make it a little bit higher. Yeah, okay, so maybe 1.5 looks okay, good. So this is going to be part of the arm, and the part of the arm that I'm talking about is this cylindrical piece, and I'm going to do rest. So on that vertical plane, yeah, on that vertical plane, which still I'm in the arm, I'm going to sketch. Let me see now. Essential, yeah. On that vertical plane, I will sketch. I'll do something like this, a rectangle. Exit, pad it, both directions, maybe 0.5, let's see what it looks like. I'll make it 0.4. Okay, good. And then on that face, I will sketch. I'm going to take that rectangle out. So, as I said, this is too much, but that's okay. Exit, and then we're going to pocket it. So to there. Okay. So what I've done here is actually this piece. Okay. Let's go all the way to the top, all the way to the top. Insert, right click, insert 3D part. Let me call this thing the slider. Slider and slider. If you don't like the top-down approach of making these assemblies, you can go and create individual parts and then put it together. It's entirely up to you. So, for example, on that face, I'll do it here on this face. I will sketch. All right, I'll sketch. I'll project that rectangle. Good, I'm going to pad it. Exit, pad, the other direction. Is that good? The other direction. And I'll make this thing as long as, yeah, that'll do it. Maybe that's too much. Okay, that's good. Very good. So all the way to the top, this is an assembly. Okay, I can move things apart. For example, first thing I'm going to do is I'm going to make a quick save here. Then I'm going to anchor the space, and I'm going to move them apart so that you can see what's going on. So here is the fix in the assembly engineering connections fix, and this is the base I'm going to fix. Do that. Where's the base? Okay, it's fixed now. All right. Now I can move these apart to show you what we've done. So manipulate. Why don't I translate, for example, I don't know this. Translate this in this direction. See that? There. This is what I've done. Okay. Say, all right. Good. This is fixed. So let's go and create our Revolute joint first. Here is a Revolute. And I'm going to use this template, so axis to axis, plane to plane, and because we're going to be controlling that, the angle between two planes. So this is number 4, this axis and this axis, okay, and let me select this plane and that plane, okay, and for the angle, because it's going to get control, a vertical plane of this and a vertical plane of the arm. So we can do it from the tree. Arm vertical plane YZ and the base vertical plane YZ or XZ, doesn't matter. Okay, so right now the angle is 0, no problem. I don't want to do any contact check. Now we do our prismatic one, so let's go ahead and do the prismatic. I will use different ways of doing it, so I will use this one, okay? Axis to axis, plane to plane, and for the offset, I'm going to look at the end plates. So this is the template. Okay, so axis to axis, how about this top and this top? These are the lines. For plane to plane, I'm going to do, for example, it really doesn't matter, I don't know, this plane and the bottom plane of this, okay? And for because it's going to get control, later on we're going to put some laws here. For the distance, for the offset, I'm going to use this end plate and this end plate. Right now there is 7 inches. If you make it 0, it's going to bring this thing and put them tight against each other. So I'm going to make this thing 0 so that actually they sit right next to each other. And then good. Okay, excellent. So let's do a quick save. Basically, I've created my assembly, my kind of constraints, joints. And now we're done here. So let me do the following. Let me go and actually create the mechanism. So I go to mechanical system design. All right. Let's check this thing. It's a mechanism representation. We're going to make it. And if you click on this mechanism manager, it shows you that there are three parts here, 2 degrees of freedom. And notice that because I used those templates and selected the right, planes, etc., one is angle driven, the other one is length driven in CATIA terminology. Okay. All right. Now, can we check it? So, for example, if you click on the mechanism player, you can see whether it's working fine. This is for controlling the revolute. This is for controlling the prismatic joint. So at least we can make a cartoon. No physics here. Now, what I'm going to do is I go to the mechanical systems experience, because we already created a mechanism. We don't have to do anything here. A scenario has been created. Notice that I'm going to create my laws. So that's what I was talking about here. You're going to create excitations. You're going to create excitations. And how do we do that? The excitations are right there. Law excitation. I'm not going to do anything. All I do is the first one. For the support, I select the first command, which is the revolute command. And notice that there is an f of x here. If I had a simple formula, I can go and type it in, but I don't have a simple formula. Okay? So, okay. So one excitation has been created. Another one for the support is that prismatic one, and say okay. Notice that two formulas have been created, and it's going to get deactivated in just a minute. Now, how do we get to writing the code? So you go to, you're in scenario, you go to tools, and there it is. Okay, so let's do that. You go to scenario, we are in scenario, you go to tools, and let's see if we can find right there. Simple rule, right there. Rule number one. Okay, and now we can start typing our stuff. And what I'm going to do is I'm going to talk to you about it as we go along, but this is what I'm going to be typing. Okay, so a couple of things. First of all, if time, now here, because it has a common time, I can use either the time for the first excitation or the time for the second one. The first one, they're going to be the same. It really doesn't matter. So if select time right here, either one of these. I'll use the first one, excitations, 1. That's for the revolute, and it really doesn't matter, as I said. Less than, our figure shows 3 seconds. 3 seconds. What figure am I talking about? I'm talking about these. If time is less than 3 seconds. Okay, for the arm is turning. So if you click on the all here, right there, because I have two things to type in, I put open braces, left braces, curly braces right there, and then we want the angle right there. This is the angle, equal to now 180 seconds, 180 degrees divided by 3 seconds. Okay, times time. Now the time, once again, it doesn't matter which one you're using the first one, time. Okay, and because we have another command, namely for the length right there, equal to, that's supposed to say 0 inches, right? Just look at it. 0 inches up to 3 seconds. Don't move anywhere. So 0. I mean, obviously, you make mistakes. We're going to come back and fix it. And close the braces. Hit return. Else, else, if, again, open braces, if excitation time less than 7 seconds, enter, left braces, okay. And what do we have here? We have, oh, the angle starts at 180 degrees. So here's the angle, equal to 180 degrees, DEG, don't forget, enter. And there is the length on the next line, equal to, based on the drawing, it's going to be, based on that graph, it's going to be the slope of that is 5 inches divided by 4 seconds. Okay, 5 divided by 4. So I mean, you can say 0 inches plus, but that's redundant. You want to do that because I closed the gap. If the gap was not closed, you have to put the appropriate gap in there. Parentheses 5 inches divided by 4 seconds times parentheses time, and do not forget to subtract that first 3 seconds from it. Okay, enter. And now we're going to go to length. Yeah. Oh, actually, this is done. This was length. Okay. Close the braces. Close the braces. Else, that's the last stage. Put this in here. Else, open braces. So the angle is going to go. The angle is going to go up again. So the angle. Yeah, angle is going to be. It was 180 degrees, and it's going to get smaller. Minus, what is this? What is the slope of that thing? Oh, sorry. This is the angle, right? 180 degrees plus, not minus. Plus parentheses. What is that? 180 degrees over 3 seconds. 180, the slope of that line, divided by 3s. If we make a mistake when we plot it, we can figure it out. Times, yeah, parentheses, time, minus, do not forget to subtract, oops, do not forget to subtract the 7 second. 7 second. This is for the angle. Go to the next line, and it's the length equal to 5 inches, and it's going to drop, minus, okay, that is 5 inches over 3 seconds, 5 inches divided by 3s times parentheses time, minus, don't forget to subtract the 7 seconds, 7s, like that, minus 7s, and close the braces. Okay, let's assume that there are no syntax error, because could be, so I'm going to click on syntax error. See right there, there seems to be a problem. Let's check it out. 5 inches, length equal to 5 inches over 3 seconds times, oh, here there's a parenthesis missing here. There's a parenthesis missing right there. And then close the braces. So there are no syntax errors. And then we say, okay, it's going to come back and say, you know what, you already have formulas here, should I deactivate it? And the answer is yes. Notice that they're so notice that I do not have a kinematic scenario here. So just click on this, click on that. These are the two excitations that I created. I want to send them to the right hand side to use it. On the parameters, 10 seconds, let's put a smaller time step here for different frames. We say OK. Now notice that if you put the cursor right there, if you put the cursor here, right click, you can plot the excitation. So what am I doing here? I'm showing you this. Okay. So right click, plot. And if I made a mistake, it'll show up here. I think these are pretty much what I had originally, so that on the slide. So that's good. That looks good. That's pretty much it. So now we're going to go and compute. Okay. So let's go ahead and find out whether it looks what I expected it. Click on that. Let me change the steps here so that I can see it better. So the first 3 seconds, this is going to turn, but the slider is going to stay in place. Let's check it out. I'm going to do it in steps. So the arm is going to check. The arm is going to rotate. Oops. The arm is rotating. I'm down to 2 seconds. Down to 3 seconds. The slider sits put. Okay, right there. 3 seconds. See that? Now, if you go to the next step, the slider begins to move. And the arm sits at that location. The arm sits put. So for seconds, let me go this thing to maybe 6, 6.2, 6.3, 6.4, 6.5. All right, that's okay. Don't let it bother you. This was not long enough to make it look better. Okay, 7 seconds. And then the arm is going to move and the slider is going to go back to where it was. See that? See, the arm is moving and the slider is going to go back to where it was. So there's physics here. This is not a cartoon. There is physics involved. All right, folks, so tutorial 24 is going to be similar type of problem, except that the breakpoints are different. And instead of a single rule, I'm going to have 2 rules. One for the slider, the other one for the revolve. All right, good luck. Of course, you can create probe here, and then you can say, okay, give me the velocity of this, acceleration of that, etc. I didn't do it, so